Alright guys, here we are again with the binomial theorem and the Pascal triangle. We are going to look at the binomial theorem a little bit different today. We are going to do the binomial expansion without the Pascal's triangle. Again, if I wanted to, let's say, have a plus b and raise it to the 10th power, then somebody should question, well, do we need to write that Pascal's triangle and then use those numbers as coefficients, or is there another way? And of course there's another way. So the only thing that I want you to notice so far is that from the Pascal triangle, this is a really nice pattern. Those numbers are always 1. All right, so pay attention to this. Those numbers are always 1s. Those numbers are always 1s. I will recall this in a second. And then if you look at this diagonal, or this diagonal, if you are raising the binomial to the second power, we have 2. Third power, the second number, the coefficient of the second term is 3, 4, 5, 6, 7, 8, and so on. All right, keep this in mind. Again, I am going to recall this in just 1 second. All right, we did this yesterday. We were able to expand the binomial using the Pascal triangle. So we would look at the numbers in the Pascal triangle. Those would be our coefficients, and then we would remember how the exponents change. The first term, the exponent is going down. The second term, the exponent is going up, and then everything nicely lines up. All right, yesterday we also talked about factorials. We will need this today. So we were able to evaluate this. We were able to evaluate this. Remember the factorial. If you have n factorial, you will take the n, multiply it by n minus 1, by n minus 2, until you get to 1. All right? So now we have the binomial theorem. And binomial theorem states, and for whatever reason my printer doesn't want to print a nice copy today, so it's going to be a little bit hard to see, but I hope you can see it well. Well, so if n is a natural number, then if you have a binomial a plus b and you are raising it to the n power, you will have the combination. And at some point of your lives, you've done combinations, but I don't know if you remember or not. I will write that definition in a second. So basically, if you have combination, this is n, this is r. N is the number that represents the total amount of objects something went wrong here. Amount of objects we are choosing from. And R is how many objects are we taking. So the number of objects we are taking, right? And the formula for that is that if we want to figure this out, we are going to take n factorial. Oops, I will lower my paper. And it's like in class, n factorial over r factorial, n minus r factorial. Notice that n always needs to be greater than r. Greater than can be equal to, but you will see that is going to be a special case. But it needs to be bigger. It needs to be a bigger number. Greater than or equal to. All right, so now let's see how this applies to what we are talking about in here. So if you want to figure out what the coefficients are, so the first one is described that out of whatever the exponent is, we are taking 0. Out of whatever the exponent is, we are taking 1. And notice how with those type of questions, we always start with the 0, and that's important, right? So the 0. Then we will take a 1, then we will take 2, then we will take 3, up to whatever the exponent is going to be. Now, I do realize that this question is asking to find the 5th term, but I find this more appropriate to just use the binomial expansion of this example. So we are going to basically just use the binomial expansion and rewrite this whole thing like we did with the previous examples using Pascal triangle. And then we can find what is the fifth term, and then we can make sure we understand why the term, what does that mean. All right, so what I am going to do is I am going to start with writing the a to the power of 7, a to the power of 6, a to the power of 5, a to the power of 4, a to the power of 3, a to the power of 2, 1, and 0, right? So we remember that. Then next I am going to say b to the power of 0, b to the power of 1, b to the power of 2, 3, 4, 5, 6, and 7. Again, notice how nicely this always matches. I know that I am going to have the plus sign in between them because this is positive. Remember that if it's negative, it flip-flops. And now the tricky part is I need to figure out what the coefficients are. Again, before we would use the Pascal's triangle and we would get our coefficient from there. So now I want you to recall what we did say about the Pascal's triangle, how the ones are always on the outer sides of the Pascal's triangle. So I kind of know that this number is going to be 1. But again, before I do write this, I want this combination notation. I'm going to slide my paper a little bit lower for a second. This combination notation is quite often written as n over r. So if you see n over r and there's no division line, that is equivalent to this notation, and that is equivalent to this factorial formula. So let's see. I am going to use this because it's shorter. So what is my n? My n is 7. My n is 7. And the first one is always the 0, right? Because we know to start with the 0, our k is 0, so, or r, we are taking the 0 objects first. Then I will have 7, 1, 7, 2, 7, 3, 7, 4, 7, 5, 7, 6, 7, 7, right? All right, so now again, based on what I did say before, I don't think I can, I can zoom out. Based on what I said before, for you to remember, this number is equivalent to 1. We can show it in a second, but I do know that this number is to be equivalent to 1. It might be a good idea to use an extra piece of paper because when we will be calculating those, it takes a little bit of room. So this is equivalent to 7 factorial over 0 factorial, and then 7 minus 0, which is 7 factorial. Those cancel out. 0 factorial. I hope you remember that 0 factorial is equivalent to 1. So this is equivalent to 1, and this is exactly what I was saying. This is equal to 1. Think of the Pascal's triangle. A to the 7, b to the 0 is 1. All right, the second term, I also want you to think of the Pascal's triangle, how in the second diagonal, that number was always equivalent to whatever the exponent is. So if we are correct, we should have 7a to the 6th, b to the 1st. But I want us to make sure we are correct. So 7 factorial divided by 1 factorial, and then 7 minus 1 is 6 factorial. 7 times 6 times 5, 4, and so on. So I can just say 7 times 6 factorial over 1 times 6 factorial. That cancels out. Look how convenient. We did get the number that we did predict that we will. All right, let's keep going. 7 and 2. So we are pulling 2 out of 7. So we would have 7 factorial over 2 factorial, and we have a difference between 7 and 2, so that's 5 factorial. Again, your goal here is to simplify, so 7 times 6 times 5, 4, and so on. But I can just say 5 factorial. Why? Because I do want to cancel those out. We cannot forget about our 2 or 2 times 1. 2 and 6 cancel out, so this is 21. 21, a to the 5th, b to the 2nd. All right, we do have to keep going. So now 7 factorial over 3 factorial, and 7 minus 3 is 4 factorial. So 7 times 6 times 5 times 4 and so on. So I'm just going to say 4 factorial because I want to simplify it with this 4 factorial. And 3 factorial is 3 times 2. But I know that 3 times 2 is 6, so this is gone. 35. A to the 4th, b to the 3rd. And I always check because it kind of messes up with your brain. A, 7, 6, 5, 4, 0, 1, 2, 3. That looks nice. All right, now where are we at? I try to keep them one under another, but I think we are on this one right now, 7, 4. So we would have 7 factorial over 4 factorial, and then 7 minus 4 is 3 factorial. So I need to go down to 7. So 7 times 6 times 5 times 4, but I can say 4 factorial because I will now change simplify it with this one. And then 3 times 2. Look at this one. This one is very similar. 3 times 2 is 6. So that is also equivalent to 35. A to the 3rd, b to the 4th, plus 7, 6. I will move this paper a little bit higher. So 7 factorial over 6 factorial. 7 minus 6 is 1 factorial. So this is just 7, and this is also something that we pointed out when we were looking at the Pascal's triangle. This is the one before the last one, so this is going to be whatever the exponent is, and this is always a nice way to check if we are doing this correctly. And just for fun of it, we know that this is a very likely 1. A to the 0 is going to be 1, so I am only going to have b to the 7, but I want you to see 7 factorial over 7 factorial, and 7 minus 7 is 0 factorial. That is the only tricky part. Remember that 0 factorial is equivalent to 1, so this is equal to 1, and that's exactly what we did say. So now, if we were to answer the question that was asked for this example 5, we were asked to find the 5th term. So 1, 2, 3, 4, 5. So this is the 5th example. And I want you to see what happens. I would be counting. So I am starting with the 7th power, 6th power, 5th power, 4th power, 3rd power. So again, you need to give yourself a little bit of time to figure out what are the exponents for our term. And then how would I find this one? Well, I would know the 7 is on the top. And because we want the 5th term, we are starting always to count with the 0. So 0, 1, 2, 3, 4, 1, 2, 3, 4. This is the 5th term. All right. So notice this nicely worked. Not only we found the 5th term, but we did the entire binomial expansion using the binomial theorem. All right, now for example number 6, we are only going to find the 6th term. So we are not going to do the whole thing. We are just going to think about the 6th term, but we are going to be looking at our top example, and we are going to use it as a guide. So because this is the 6th term, my x is going to be what power, and my y is going to be to what power. So again, let's think about this for a second. You think about this for a second. What are we going to get for our 6th term? Well, maybe I should leave you with this one and have you think about this one. and have you do this as an assignment. But we can do together the next one where you are just looking for the coefficient of x to the 7th, y to the 2nd term in this particular sequence. Notice that this sequence is going to be or a little bit more difficult because we have the 4x and then 3y. So how is this going to affect our coefficient? All right, guys, just to fast forward a little bit, I want you to see what just happened. So now we are on example number 7, and we are looking for the coefficient of x to the 7th, y to the 2nd of this magic thing. And I want you to see how there are some numbers with x and y. So what I am trying to figure out is what number of the term is that. So if it was, because it is to the 9th power, if x was to the 9th power, it would be the term 0, and this is again always something to remember about. We do have to have the term 0. If it was 8th power, then it would be 1. If it would be 7th power, it's 2, and that's exactly what we do have. So I need to figure out the combination if I take 2 out of 9, and then 9 factorial over 2 factorial times 7 factorial. So here is my computations and a little bit of simplifying. And notice I do get the 36 as an answer. Now again, this is not the end of the story because of my 4 and because of my 3. So now what do I need to do about those? Well, my number that I have in front is 36. But then I do know that this one would be raised to the 7th power, right? And the y term, which in my case is the 3y, negative 3y, is going to be raised to the 2nd power. And my answer is that this is going to be a really big number. What you would have to do is raise the 4 to the 7th power, negative 3 to the 2nd power. Well, that's easy, that's 9. So you will take the 9, multiply it by this, and multiply it by 36, and you would get the coefficient that works with that one. Example 8 is something that I would want you to do. And if you turn the page over, I would also want you to do example 6. And this one is, it's going to be fairly long. You are going to expand it like we did with the example number 5. And then I also want you to try example number 7. And then I will check if I want you to do anything on the exercise page, all right? Again, I do know that this takes a little bit of time, but it is not only you are practicing the binomial theorem, but you also are practicing how to do the factorials, how the combinations work, and in general you're working on beautiful mathematics. I think this is the last part from this unit. We are then going to move on to limits, and this is something that normally you would start the calculus class with. So this is for a good thing for seniors. So when you go to college and when you take calculus class, you will have a basic foundations. And for everybody else, again, anything with mathematics is beautiful. So you'll get to learn something new. If you have trouble with this, see me during my office hours tomorrow, and we can work on this together. Okay? Otherwise, have a great day, guys.